Good day, everyone, and welcome aboard. I am Elmer Jimmy, and I will be discussing about pneumatic power systems Part 1. We will be using the world-renowned amateur e-learning platform to discuss this topic. The amateur e-learning platform is designed for online distance learning, hence it can be used 24/7 and at your own pace of learning. So this is compliant for today's requirement for blended learning, meaning this platform can be used for synchronous and asynchronous modes of learning. It has built-in or embedded virtual simulators that has the same capability and configuration as its hardware counterparts. Our team is composed of Mr. Reniel A. Sabsedi, our secretary Ms. Rebecca de la Cruz, and myself. So what are we waiting for? Let's start the webinar. So before we start our session, allow me to present the specific objectives of this webinar. At the end of the session, the participants should be able to, number one, define pneumatics and identify some of its applications. Number two, enumerate the different pneumatic system components. Number three, identify the pneumatic safety rules. Number four, identify the pressure regulator components. And number five, identify the air filter components. So what is pneumatics? Pneumatics is coined after the Greek word pneuma, which means air. So fluid power is a method of using pressurized fluid to transmit energy. Although fluid is commonly thought as a liquid, it is actually a liquid or a gas. Hence, there are two branches of fluid power. So we have pneumatics and hydraulics. Pneumatic systems uses compressed air or other gases to perform work. A typical example is the robotic arm shown at the left that uses compressed air to move its actuators in order to perform work. On the other hand, hydraulic systems uses pressurized oil or other liquids to perform work. One of the applications of hydraulics is used in the excavating equipment or backhoe shown at the left. The backhoe utilizes pressurized hydraulic oil to perform work. From the picture, we can see the massive hydraulic cylinders which are connected to the movable booms of the said excavating equipment. Here are some of the applications of pneumatics as part of the modern industry. It is utilized in the manufacturing, construction, and transportation sectors, to name a few. In the manufacturing sector, it can be used for robots, power tools, or painting. In the construction sector, it can be used for rock drills, pneumatic drill, or air chisel. While in the transportation sector, it can be used for the truck brakes, air shock absorbers, or vehicle control devices. Since both pneumatic and hydraulics are classified under fluid power, it therefore has unique similarities. Both pneumatic and hydraulic actuators, whether linear or rotary, can be stopped without damaging them. As a matter of fact, these actuators can be reversed quickly without using a clutch. Another similarity is that actuator motion can be linear or rotary. This is true to both pneumatic and hydraulics, and actuator speed is easy to control. Here are some advantages of pneumatics over hydraulics. Higher speeds can be obtained with pneumatics. Pneumatics cannot leak oil, so they are better suited to be utilized in the textile, electronics, food processing, or even in the pharmaceutical companies. Pneumatic system components are lower in cost than hydraulic components since its medium is only compressed air as compared to the expensive hydraulic oil. If there are advantages of pneumatics over hydraulics, here are its disadvantages. Pneumatic systems usually don't operate above 150 psi, suiting them only for lower force applications. The main reason for this is that air can be compressed. That's the reason why, for handling heavy loads, especially on board ships, like lifting or lowering the anchor, handling mooring lines, etc., hydraulics is utilized instead of pneumatics. Usually, pneumatics is utilized for control valves, garbage compactors, and opening and closing some doors. Another disadvantage of pneumatics over hydraulics is that the compressibility of the gas causes pneumatic actuator motion to be rough, not smooth like hydraulics. So this is the same reason as the limitation of pressure, because air is compressible as compared to hydraulic oil. There are 5 basic pneumatic system components. First, the power input device, which is a compressor. For the pneumatic circuit trainers, the compressor is usually compact, but for actual installations, such as onboard ships, the compressor is quite large and normally has 3 stages, and the compressed air is stored in large air tanks. Second are the control devices, which is composed of the 3 types of control valves: pressure, flow, and directional. Next are the power output devices, which are the pneumatic cylinders and motors. The conductors is the term used to refer to the pipes, fittings, and flexible hoses. And lastly, the gas in the form of a compressed air. This is one of the hardwares used by Amatron. From this compact setup, you can see the different basic pneumatic components utilized for the various experiments in basic pneumatics. The components includes pressure regulator, combined with the filter, pressure gauges, flow meter, pneumatic cylinders and motor, control valves, T-joints, and the hoses with quick connect-disconnect couplings, which makes the system efficient during the conduct of experiments. Each hardware manufactured by Amatron has a corresponding virtual simulator which is embedded in the e-learning platforms. Take note that some of the components are made of transparent plastics for the trainee to see its internal operations. The pressure gauge is one of the most important components in any system because it indicates the amount of pressure in a pneumatic system. Technicians or engineers read these gauges to determine if the machine is operating properly. Most pressure gauges have a faceplate that is graduated in either US customary units, PSI, or SI units in Pascals. A pointer rotates around the scaled faceplate as the pressure changes to indicate the pressure in the system. Function of a schematic diagram. Schematic diagrams are visual shorthand drawings that use symbols to represent each component in a circuit. Schematics are used because they can be drawn easier and faster than pictures. Shown is a typical schematic diagram of a basic pneumatic circuit. Let's start from the source of the pressurized air or the air source, which is the compressor. From the compressor, it will pass through a conductor, and in this case, a flexible hose towards the system. From the compressor, it will pass through the main shut-off valve. After the main shut-off valve, it will pass through the air filter to condition the compressed air. To condition the compressed air means removing impurities such as air particles and moisture that may cause damage to the pneumatic components in the system. The air filter is usually integrated to the pressure regulator. Next, the conditioned compressed air will pass to the pressure regulator. As the name implies, it regulates the pressure downstream depending on the pressure required. From a higher pressure, it maintains a lower downstream pressure. Its function is more or less similar to the step-down transformer in an electrical system. Just like what we have discussed earlier, pressure gauges are used to monitor the pressure in a particular location in a pneumatic system. From the diagram, we can see 3 pressure gauges that are installed to monitor the pressure after the pressure regulator, before the directional control valve, and in between the flow control valve and the pneumatic cylinder. These pressure gauges will help determine whether the system is functioning properly. After exiting the pressure regulator, the pressurized air will flow through the manifold and into the directional control valve, which is in this case a 5-3 directional control valve. As the name indicates, this valve is used to control the direction of the compressed air and is usually positioned before a pneumatic actuator. From the diagram, we can see that Amatrol are using transparent valves made of plastic to show the internal parts of a functional valve. Depending on the pneumatic circuit, but from this diagram, a flow control valve is positioned between the directional control valve and the pneumatic cylinder. This valve controls the airflow to an actuator, which in turn controls its speed, since the speed of the actuator is a function of flow. Meaning, the higher the flow rate, the faster the actuator will move. After the directional control valve, the pressurized air will then flow to an actuator. The actuator can be a pneumatic motor for rotary motion or a pneumatic cylinder for linear motion. Based on the diagram, a pneumatic cylinder is used. The piston and rod of the cylinder can extend or retract depending on how the directional valve is manipulated. Shown are the basic schematic symbols that may be combined to form symbols of various other pneumatic components. For example, the symbol for an air motor shown, combined with a 45-degree arrow, makes the speed of the air motor variable. So the air motor will form a new component from a mere reversible air motor to a reversible and variable speed air motor. Any component, whether pneumatic, hydraulic, or even electronic, if combined with a 45-degree arrow, will indicate that it is variable. When it comes to symbols used in the schematic diagrams, there are 3 standards used, which was developed by the following organizations: the National Fluid Power Association, or NFPA, the American National Standards Institute, or ANSI, and the International Organization for Standardization, or ISO. Note that the International Organization for Standardization uses ISO instead of iOS because it's much easier to remember. ISO is from the Greek word isos, meaning equal. just like isobaric or equal pressure, constant pressure, or isothermal or constant temperature, to name a few. The United States uses their FPA, ANSI, and ISO standards, while the rest of the world uses the ISO standard. There are 6 safety rules used in pneumatic. Although most pneumatic power systems operate at pressures of 100 psi or less, special care must still be taken when working with pneumatics. Observing proper safety procedures will help you protect yourself and your equipment. So here are the 6 safety rules used in pneumatics. The first rule is do not point compressed air at eyes, ears, mouth, nose, or skin. For example, do not block a pressurized line with your fingers or hands as this can penetrate the skin. The second rule is to properly secure any hose or device that contains compressed air. Mechanically test all connections first before pressurizing, so they do not blow out. Tie down loose air lines to keep them from whipping. Also, always turn off the air pressure before connecting equipment and gradually turn up the pressure while looking for loose lines. The third rule is to use proper pressure when cleaning with air. So if there's a need to use air to clean the components, reduce pressure to 30 psi or below to clean or blow parts. The fourth rule is to wear safety glasses. Safety glasses with side shields should always be worn when cleaning or working with compressed air. So this is not how to do it. I forgot to wear the required safety glasses while conducting a demonstration to a group of BSMRE cadets from a local maritime school in Tacloban City. What I am doing is attaching some hoses to the pneumatic component of the pneumatic circuit trainer shown, in accordance with the particular pneumatic circuit. So this was taken while I'm still connected with the National Maritime Polytechnic, NP, in Tacloban City. So why safety glasses is important? Because once the system is pressurized and the hose was inadvertently detached from its connection, the hose will create a whipping motion and might hit your eyes and cause an injury. Next rule is to use containers strong enough to safely hold compressed air. Use only approved pressure-rated containers for compressed air storage. And the last rule is to avoid continuous noise pressure. The noise caused by pneumatic component exhaust can be damaging to ears at certain levels. I prefer to use the ear muffs because the earplugs may cause an ear irritation. There are 2 types of earplugs used, the disposable and the more expensive washable type. Next, we have a pressure regulator valve function and a sample application. The needed air pressure for each application in a factory or anywhere else is often different and less than the pressure available from the main compressed air line. The compressor creates pressure, not flow. Unlike hydraulic systems, where the pump produces flow, not pressure, an air compressor produces pressure, not flow. Flow only occurs where there is a difference in pressure between 2 points in the system. How does a pneumatic pressure regulator works? But before we proceed to that, allow me first to enumerate the parts of the pressure regulator and briefly discuss about it. First, we have the adjustment knob here. So as the name implies, it is used to adjust the pressure downstream. Okay, So by turning the adjustment knob clockwise, increases the pressure, and by turning it counterclockwise, it reduces the pressure. Then we have the body of the pressure regulator, and of course the adjustment spring, which is controlled by the adjustment knob. And here we have the pilot hole, okay, which is connected through an annular gap or hole to the bottom side of the piston. So this is the piston here, which is connected to the poppet and the poppet spring. So here we have three forces involved. We have the downward force, which is created by the adjustment knob onto the spring and into the piston, which is also connected to the poppet. And then we have also the poppet spring, which is poppet spring force, which is directed upwards, similar to the um, pressure or force in the pilot hole created through the pilot hole. Okay. Then we have the vent holes. So this is very also important uh, part of the pressure regulator, because we cannot help it, but some of the pressurized air will move through this void here through the piston, because the piston normally is not perfectly sealed. So some of the pressurized air will really transfer to the other side here through the gaps on the side of the piston. So what will happen if there's no vent hole? Uh, the pressure here, the pressurized air will be accumulated, which prevents the normal functioning of the regulator. So that's why vent hole is uh, placed here, so that the any pressurized air that leaks through the piston will be vented to the atmosphere. Okay, so we have here the connection from the compressor. Usually we term it upstream, and the pressurized air. I did mention that in the pneumatic pressure regulator, there are three forces involved. We have the downward force, which is created by the spring on top side of the piston, and which is controlled by the adjustment knob. And we have the poppet spring force moving upward, counteracting this force going down, plus the upward force again created by the pilot pressure, uh, which is acting on the downside of the piston. So the pilot force here is a function of the downstream pressure. From the formula, pressure equals to force per unit area. Force therefore is equal to pressure times area. So as the pressure increases here, so is the force, this pilot force, which is moving upward. Okay, so if the pressure downstream is less than the set pressure by the adjustment knob, so what will happen? The pilot force here is quite weak. So the downward force, which is created by the spring and controlled by the adjustment knob, will push the top side of the piston to move downward. So you'll notice that this piston is connected through the poppet valve. So the poppet valve will move this way, overcoming also the poppet spring, thereby increasing the opening here. Okay, so the pressure from the compressed air, will flow through this gap here to the downstream side. So as the pressure in the downstream slowly increases, okay, so is the upward pressure here created by the pilot force. So as the pressure force increases, it will push the downside of the piston upward, slowly overcoming the downward force plus the poppet spring force. So if the pressure here is already at par or conforms to the set pressure by the adjustment knob, so these three forces will now become in equilibrium. So the two upward forces will balance the downward force. In the previous slide, I did emphasize that once the downstream pressure conforms to the set pressure in the adjustment knob, set by the adjustment knob, so these three forces, vertical forces, will be in equilibrium, meaning to say the two upward vertical forces will balance the down force created by the spring on the top side of the piston. So the gap here will remain constant. So the flow of the high pressure air from the compressor through this gap here to the downstream will be constant. So what will happen if the demand on the downstream increases? So normally the pressure will lower. So is the pilot force here. So again, the process will repeat by itself. The downward force created by the spring on the top side of the piston will move the piston and the poppet downward, so thereby opening more here in this part here, allowing more compressed air to flow until the downstream pressure conforms to the set pressure created by the adjustment knob. So in that case, these three forces again will be in equilibrium. So what will happen if the flow of air downstream is blocked? So let's presume that a valve here, somewhere here, is closed. So that's why the air now from this part here, from the part where the air is blocked, through the upstream compressor side will now become static or not flowing or steady. So when that happens, Pascal's law will apply. Blaise Pascal's law states that the pressure at any point within a static fluid, so when I say fluid, that could be gas or liquid, is equal in all directions. So if that is the condition now, the pressure from this part here is equal in all directions. So this pilot force here will increase because the pressure from the compressor is quite high. So once this one increase, it will push the downside of the piston upward, overcoming the downward force created by the spring and controlled by the adjustment knob. So since the piston is connected to the poppet valve, so the poppet valve will also move upward until the gap here is closed. So meaning to say, if the downstream pressure or flow of air is blocked, automatically the system will stop, or the flow of air from the upstream to the downstream will be closed through the poppet valve. This is the schematic symbol for a pressure regulator. It consists of the following components. So we have the flow line, the pilot line, the spring, which is usually a variable because of the 45-degree arrow. So since the spring here is controlled by the adjustment knob, and then we have the pressure gauge and the self-bleeding feature or the vent hole as indicated in the picture or image that we have seen before of the pressure regulator. Pressure regulator in a circuit. As shown, the regulator with the pressure gauge is used to reduce the supply pressure to the control and power circuit of the machine. Normally, it is located between the filter and the control valve. Usually, the filter is already part of the pressure regulator, and the pressure gauge here indicates the pressure downstream. What makes the Amatrol system unique is that its e-learning courses is embedded with a virtual simulator which can be used by the trainees and instructor alike in performing the experiments. These virtual simulators has the same capability and configuration to its hardware counterparts. So the trainee has the option to use the virtual simulator or the hardware. The obvious advantage of the virtual simulator than its hardware counterpart is that it can be accessed online 24/7 at their own pace of learning, no consumables, safe to use, and repeatability, meaning the trainees can use it until they have gained mastery of the subject or topic. One of the most important components in a pneumatic system is the air filter, which is usually part of the pressure regulator. The compressed air used in pneumatics comes from the atmosphere. That means that the air supply can contain dust, pollution, and other particles which are too small to see. If a particle is large enough, it can prevent close-fitting parts from working smoothly. That is the reason why an air filter is needed in order to remove these impurities and particles. An air filter is a device designed to clean the air before it enters the pneumatic system. It will also remove water droplets from the air supply. All pneumatic systems should be installed with one or more air filters to keep them working properly. By removing the particles in the compressed air, it can prevent malfunctions caused by the particles in the long term. It will lengthen the product life, thus saving on maintenance costs and downtime. So here is a cross-sectional view of a typical air filter showing its components. So first, we have the inlet port. This is usually the port where the untreated air enters the filter. Next, we have the deflector plate. So the deflector plate causes the air to spin inside the filter bowl. So this swirling motion causes centrifugal force, which separates the larger particles from the air and collected at the bottom of the filter bowl. So we have also the filter element. So after passing the deflector plate, the filter element traps the remaining smaller particles. We have also the baffle. So the baffle acts as a partition or a weir to control the path of the airflow. Next is the bowl. So the bowl collects the water and dirt particles and serves as the outer casing of the air filter. Another important component of the air filter is the manual drain. So the drain plug allows the collected water and dirt particles to be drained. As a practice, before operating the pneumatic system, this component should be operated first in order to remove the impurities and particles that has been separated by the air filter. And the last component of the air filter is the outlet port. The air exits the filter through the outlet port towards downstream or to the system. The air enters the filter through the inlet port. The deflector plate causes the air to spin inside the bowl. So this spinning action throws the heavier particles, such as dirt and water, against the sides of the uh, filter, where they then drop to the bottom. The air then swirls into the filter element, and the smaller particles are trapped in the filter, and the clean air passes through the outlet through the center part of the filter. The baffle plate, this one here, prevents the collected particle from exiting through the outlet due to the compressed air and the particles in it. So here we have a high pressure part here because of the compressed air. So the baffle will prevent the collected particles from proceeding into the outlet port. The particles that have collected in the bowl must be drained before the level reaches the bottom part of the baffle. There are two types of drain plug. One is manually operated, as shown here, and the other one is automatically operated. The manually operated drain valve, as the name implies, is used to drain the filter manually, usually before the system is operated or as needed. But if the filter operation is high, it is recommended to use the automatic type, which discharges the collected particles automatically. That concludes our webinar for today, and I hope that I was able to impart knowledge and skill to all of you. By the way, in order for you to acquire the certificate for this topic, all of you are required to answer the short assessment that will be provided by the Secretariat through a link. After answering the assessment, it will be checked outright and a notification will be sent to you regarding the result of the assessment. The passing score is 75%. Good luck. To recap, we have discussed about the following subtopics. We have defined pneumatics and identified some of its applications. We have enumerated the different pneumatic system components. We have identified the pneumatic safety rules. We have identified the pressure regulator components, and also we have identified the air filter components. If you have any inquiries about High-Tech Power Inc., please contact the following persons. Thank you very much and stay safe, everyone.